Today we are going to talk about creativity in maths classroom, which can be a way forward for a democratic learning space. As the conceptualization of this topic goes back to the you could say the terror, the fear, uh, disinterest our students face about mathematics, because we have seen majority of students across the world, and it is we have considerable reliable data which says that students generally do not like mathematics. They find it dull, boring, meaningless, useless. And then there are students who are not interested pursuing the subject. They develop fear for the subject, phobia, anxiety. So there are many learning and psychological issues, cognitive and psychological issues related to maths learning. So within that scenario, can we have a breathing space for creativity so that it becomes a classroom where voices which are not so mathematically perfect can be heard, can be celebrated. So this presentation today and our long discussion will be based on this experience. So let me first introduce about India, because many of our colleague today, they would like to know a bit about India, because yesterday when we were talking, when we were doing pre-testing for the seminar, so Barbara told me to briefly talk about the education scenario in the country. So India is located into subcontinent southeast, southwest, the Asia, so Asian continent, and we are in the southern part of it. If we talk about in terms of numbers, so we are the second populous country in the world. We are the youngest nation with the median age of 29 years. And the right to education is a fundamental right in the country. India is signatory of UNESCO education initiatives, whether it is on inclusive education, sustainable development goals, or global educational goals. So we are a signatory of all these conventions and declarations. We have on the other side, if you see, we are a country with highly diverse language background, cultural diversity, social diversity, geographical diversity. We are There is a lot of economic disparity, and we have religious diversity also. So a very multilingual, multicultural country we are. There are 22 official languages as per the 8th schedule of the Indian Constitution. And we speak, there are almost 19,500 languages or dialects spoken as mother tongue. So, within this diversity, when we are talking about education, so how do we place education in this diverse context? And then coming to the maths education, okay? So education is the joint responsibility of center and state. Ministry of Education heads the national responsibility, and then there are departments of education as per all the states. We have national education policy, which is the navigator for education related deliberations at school and higher education. Currently, we are in the process of implementing National Education Policy 2020. Sorry, this is 2020, not 22. So the India rolled out the current National Education Policy. It was rolled out in August 2020. So this is typographic error. So now we are in the process of implementing National Education Policy 2020. We have National Curriculum Framework, which is an advisory framework to design curriculum goals, learning outcomes, and teacher preparedness assessments. We have an independent national council, NCERT, we call it NCERT, National Council of Teacher Education, Research and Training, which works at center level in advisory role. And then we have SERT, which are State Council of Teacher Education, Research and Training. So these are independent research bodies which works closely with Ministry of Education, departments of education to achieve the vision of the education policy. So now we have central boards, state boards. We have one central board which is called CBSE. Then there are state boards, international boards, and independent boards for which takes responsibility of assessment time to time. Then we have National Council of Teacher Education. This is again an independent body under Parliament Act, which is responsible for maintaining ethical practices for teacher education programs in the country. So we have degree level programs, diploma level programs, and yes, research level programs, which are MEd, MPhil, and PhD. Okay, this is a brief. This is just a snapshot of NCERT, which is the national body, national advisory body for school curriculum. And this body, this organization is responsible to prepare model textbooks as per the curriculum framework guidelines. Okay, now then the state bodies, state committees, state institutes are free to redesign these textbooks. They can create their own fresh textbooks or they can use the same textbooks. So in this way we have we have center in the advisory role, in the hand holding role, in the facilitating role, and then there are states who have freedom to bring in local culture, local context, local dimension to the curriculum and make curriculum more appealing and relatable to students. Uh, the vision statement. So let's talk about where do we place math education, math learning goals within the education, the national education framework. So the national education framework has prepared a position paper on mathematics education. The position papers are prepared for almost all the subject domains, in addition to assessment and inclusive education. So the math position paper, which was prepared in 2005, and the new education the position paper and maths framework is in preparation stage as per the current education policy 2020. So this so it has 7-point vision statements. So it says that all children must able to enjoy mathematics. So the vision statement says that all children should enjoy mathematics, all children must learn important mathematics. Uh, Children should see maths as something to talk about, to communicate, or to discuss among themselves. And children should be able to pose and solve meaningful problems and develop logical thinking. And they should be able to use this logical thinking in their working and in their expression. Children must understand the basic structures of mathematics, and teacher must be able to engage every child in the class. So if you see, this is 7-point vision statement. It is a huge wish list, I should say, when we see the reality and scenario in the regular classroom, regular maths classroom. If we talk about the pedagogical framework, so we believe in we propose a constructivist approach of teaching maths, which is based on exploration. The curriculum is sequential and incremental. So the same concept is taken uh, at different grades with different difficulty level. So the framework suggests a broader content, broader area, broader content domains, and less taller. So we, instead of the vertical complexity, we believe the our curriculum design, the proposed curriculum design, is multiple concepts, but maybe at simpler level. And students in grade 11, 12 can take, who want to pursue careers in mathematics or in allied subjects, so they can learn concepts at greater complexity and depth. uh, it is encouraged to have localized and experiential curriculum and activities in the classroom instead of product oriented learning outcomes. Emphasis is on process oriented outcome, how children think, how children process mathematical learning. So mm, and it is more conceptual and less procedural, and maths learning and pedagogy is developmental as students move from the lower grade to higher grades. The complexity of concepts and its application gradually increases. So this is a snapshot of grade 1 textbooks. So it is more child centric, pictorial, and there are instructions and notes for teachers how to best use the textbooks. So generally our textbook are learner centric. Focus more on concepts where there are examples and non examples. Procedure are supported by examples and exercise. There are exercises for more practice. There are pictures and figures and constructions for better elaboration. Efforts are made to make textbooks more inclusive and gender sensitive, and the textbooks are translated into regional languages, okay, so that students can understand, because we emphasize the early years of education and mother tongue to develop better foundational understanding of concepts and procedures. So textbooks are translated into regional languages. I'm not going to the textbook, the detailed textbook, which I thought I'll be doing, but because we have wasted some time in setting up the technicalities. So this is the place where I work as a professor of math education. It is Cluster Innovation Center. It is a department of University of Delhi, and here we run a master's level program which is called MSc Mathematics Education. It is a unique program in the country, because otherwise in our education departments we have general Master of Education, so MEd, which is a professional course, or MA in education. But this is one program which is domain specific, and we run a matrix which is a math education society. If I could give you a glimpse of that. So this is the matrix. This is a society run by the students, where teachers are more like advisors, but students run it. So it has various kind of learning resources prepared by students. We have the concept of maths lab. So these are mathematical games based on the curriculum, focused mathematical games, storybooks, storyboards, e-resources. So this society, this oh, wait a minute now. Yeah, so this society works on the ideas of fun loving mathematical learning. So we also run a gifted education program, uh, where we work on identifying talent in maths and science, and then how to mentor them. So we have run this as a national flagship, national level program to the government of India, and where we have worked with children from different demographic background, and so we partner with schools, we have policies on it, we have multiple kind of resources. So math education, finding maths talent is one of our forte. So this is briefly about my institute and the kind of work we are doing. So we closely work with schools, we closely work with the policy designers, curriculum designers, to help them develop innovative methods and resources for to make maths learning more easy and fun for students. Fine. So now, okay, now I'll talk about the topic of today, which is creating creative learning space in a maths classroom. So it this is divided into three parts. So first of all, let us revisit the nature of mathematics. So generally, mathematics is seen as an abstract world of mental concepts to the real world of physical entities without being completed located in either of the two. Ian Stewart in 1995, in a revised edition of the book What is Mathematics, beautifully talk about, make three levels of distinction on nature of mathematics, where he says formal mathematics, which he describes as rules of grammar. So where there are local rules, so there are rules of solving an equation, there are rules of addition, there are rules of finding a square root, and correct applications of local rules. So you have rules for integration, different kinds of integrations. Okay, so this is the most basic mathematics, so the little scope of experimentation, exploration, creativity, uh, well defined rules and well defined solutions. The second level is meaningful mathematics, which it describes as journalism, which has an ability to tell an interesting story. But in mathematics, the story must be true. And the best mathematics, which excites mathematicians, which excites math lovers. It's like literature, which brings a story to life and involves you intellectually and emotionally. So you become part of that story, and then you take pleasure in solving, experimenting, extending, contradicting the mathematical formulas, mathematical knowledge, theory, corollaries, statements. So another part, you could say maths is axiomatic in nature, because we have set of axioms, and then there is the entire structure is based on that axiom. You change the set of axioms, and then you have entire different alternate structure of mathematical the rules and formulas. You could say simply it is study of patterns. It is language of universe, as the Galileo said. It involves abstraction and generalization. It has other characteristics also. It is based on precision. Mathematics is a highly precise language, you could say. So it has notation, symbols, expressions, and which is very sophisticated and precise language. It has accuracy because it is a very ideal, perfect world. It is based on the law of parsimony, because we talk about, with the minimum input, we talk about the maximum output, where we have algorithms, we have definitions, and uh, we try to, with one example, we try to extend one example to all the cases which has same characteristics. We mathematics is based on algorithms, so we develop algorithms which can be used for infinite cases of like characteristics. And yes, there is convergence to the correct, perfect, and ideal solution. So this is how mathematics is being presented to students. And when it is presented this way, then definitely there is no scope of error because answers should converse. Any method you develop, it should be developed as an algorithm because it should be able to extend, generalize to all kind of like cases. So within this very structured, uh, formal overview of mathematics, which is given in textbooks and presented to students, and this is how they are being taught, there is a term called mathematization. So I'll talk about mathematization little later. Yeah. So mathematization is basically what? It is understanding your experiences from a mathematical lens. And when I'm saying understanding, what does it mean? It means you are able to communicate mathematically. That communication can be verbal, can be written. You can draw, you can construct, you can enact, you can solve, and there can be multiple forms of expressions and communication. Okay, now here I'm talking about mathematization, but here we are talking about precision, accuracy, parsimony, algorithm, conversion. So here there is freshness, there is openness, there is freedom, and here you have very closed boundaries and high standards which sometimes students, and within that it is abstraction, it is too much away and distanced from reality. So students, many a times many students are not able to bridge this gap. Okay, I later talk about why problem solving is important here. So the problem is there is overemphasis on deductive postulational character of mathematics. So there are postulates and we go into deductive approach of doing. But mathematics is a combination of logic and intuition, analysis and construction, generalization and individualistic approach, usefulness or immediate utility to the desire for aesthetic perfection. Okay, so we must move from formalized mathematics of mathematical formalization and manipulation to which leads to frustration and disillusion to a more creative, open, and intuitive mathematics. From empty drill of problem solving to a more divergent approach of problem posing and problem solving, because empty drills are generally it deprives intellectual independence. So and so this, let's talk about what creativity. I'll just briefly touching these points. If we talk about, so creativity is a very complex concept, not very easy to understand. I know one of my dear friends, uh, long back, I think somewhere in 1996, 97, she wanted to pursue her PhD in mathematical creativity, and she could not defend her proposal because people in the board of studies could not agree that mathematics can be a creative subject or there is scope of creativity in mathematics. So so it's not it's a complex concept and it's not very easy to understand or deconstruct, but there are some very beautiful definitions of creativity. The simplest definition by Gardner, which says the human mind is inherently creative and creativity is an integral trait of human genius, which Renzulli, Guilford, everybody has agreed upon and stressed upon. Creativity brings novelty to routine practices, and creativity ignites innovation and change. For an idea or a product to be creative, it should be original, novel, effective, acceptable to the reference group. So, acceptance to the reference group is an important criteria when we are talking about creativity. But again, coming to this point, acceptance again brings complexity. brings boundary, brings to some extent rigidity, and can curtail the freedom of free thinking, creativity, then there are many researchers and experts who have talked about that creativity lies at the heart of problem solving. So many people equate creativity with problem solving, particularly when they talk about creativity in mathematical domain. uh, uh, Professor, myself and Professor Marcia Delcourt, who is one of the uh, co-partner and co-researcher in our work on mathematical creativity. So we worked with educators in India and United States, and we tried to find out what is their understanding on creativity. And so this is just an analysis of what educators, and these educators were math teachers, school principals, and the academic heads in the schools. So what is their understanding of creativity? So this diagram actually talks about, represent the analysis of their responses. So everybody believed that creativity is an ability, and this ability is an innate ability which is developed and nurtured. This ability helps in different kind of cognitive processes, and these are various cognitive processes involved in a creative activity. This cognitive process, these cognitive acts lead to some outcomes which are creative, and these outcomes can be idea, process, solution, problems, etc. Now, these outcomes, to be creative, they should have these attributes. So it should be out of the box, it should have flexibility, unique, original. So this is, so the first thing, creativity is an ability. It is a potential. Since it is innate and it can be nurtured and developed, so that means it is a potential which can convert into ability, and which can ability can convert into accomplishments and achievements. So let's come to nature of mathematical creativity. So mathematics from so see the paradigm shift. Mathematics is a rigid, sophisticated, formal discipline to mathematics is an open, ever-growing, creative discipline. Okay, the E.L. Mann, in his the famous article on essence of mathematics, talks about, claims that essence of mathematics is thinking creatively, not simply arriving at the right answer. Then Balka, Haylock, Kilpatrick, all they have given beautiful definitions on mathematical creativity, which entails conceptual knowledge, risk taking to flexibly apply conceptual knowledge in new applications, problem finding, problem creating, and problem solving. All are part of mathematical creativity. Creativity in mathematics, or in general, often begins of an individual discovering something new, although the result may be known to others. This is another important dimension of mathematical creativity. Whereas Shamlin and Moon consider divergent thinking as an important component of mathematical creativity. Uh, Hong and Acqui found that creatively talented students in mathematics were more cognitively resourceful than people who were more academically bright. This finding is important. Why I am highlighting this findings here? Because it emphasized that why it is important to nurture, foster creativity in the classroom. Even academically bright students are not much resourceful as compared to creatively talented students. Okay, these are some of the definitions. This presentation will be available with Barbara, so interested people can take the presentations there. Now, this model is important, Kaufman and Bechto's model of 4C creativity. So we start with mini C creativity. These are those simple creative activities and discoveries that occur in our day-to-day lives. They might not be high in creativity, but they are valued because of the personal meanings of individuals and the role they play in the learning process. So when we are talking about students, mini C creativity is important. It is important to give scope to develop mini C creative, because mini C will then further lead to little c, pro C and big C. The little c creativity talks about these are initial acts of creativity that indicate creative potential. Pro C creativity, when some high level of professional activity is performed, so this is that ability. And big C creativity is the highest level of creativity required in creation of new knowledge and innovation. So the people who have big C creativity, they make remarkable contribution uh, to the communities and societies. So we can say Einstein, Newton, Descartes, all these are the great people whom we can put in the category of basic creativity. Okay, this is another important the differentiation where we talk about professional level mathematical creativity and school level mathematical creativity. So professional level, so this is creativity which is which is demonstrated by the skilled mathematicians at highest level of research and knowledge creation. And school level mathematical creativity is demonstrated by school students who are still in the learning and development stage, and even the college students we can put under the same category. Within so keeping in mind these two differentiations of creativity at a different level, let's revisit some premises of creativity. So the first thing is, the first premise is the human mind is inherently designed to think creatively. Creativity is the second premise, creativity is developmental. So when we say human mind is inherently designed to think creatively, that means every student in my class can be creative. Maybe at mini C level, not at big C level or the little c level, but definitely all my learners are able to think differently. Creativity is developmental. If stimulating, challenging, rightful learning ecosystem is provided to children, every child can reach to the next level of creativity. Creativity needs time for deep thinking, subconscious thinking, and reflection. So it is not, you cannot straight away jump to the big C creativity or pro C creativity. It requires lot of time, lot of thinking at subconscious level. So even the wow movement of a creative act derives from our understanding, analysis, and reflections of our past experiences. So it is a gradual procedure from the simplest level of a creative act to the highest level of a creative performance or creative accomplishment. So our work, so when we were thinking about mathematical creativity, so we were talking about creating spaces in our classroom for to foster mini C and little c creativity, because we are talking about students who are still at the learning stage of mathematics, beyond formal and structured mathematical knowledge and beyond problem solving. So the flexible thinking and expression of translating mathematical understanding in a mathematical and non-mathematical context is the center of our discussion. Okay, so uh, so when we are talking about what does it mean to be a democratic learning space in maths classroom, so we believe that Even imperfect voices are accepted. When I'm saying imperfect, voices which may not fall into the rightfully, we can put into the formal mathematical categories. Okay, so and different modes of ideas and expressions are encouraged. So it is, somebody may not be writing, giving answer in the accepted mathematical notations, but there can be different ways of expressing the conceptual understanding. Individual experiences and mathematical understanding of those experiences are appreciated. So, uh, uh, and then different levels of learning are accommodated, and individual differences are celebrated. So, we believe that in a democratic classroom, there is space, scope, acceptance, and accommodation for all students. There can be possibilities of expressing their understanding in different modes. There maybe we accept and appreciate that different students may demonstrate different levels of learning, and every response can help us to get some understanding of students' conceptual understanding or misconcepts. Okay, so we talk about, so we believe that extending mathematical learning outside the mathematics curriculum, so it is beyond textbook, it is beyond maths curriculums, and it is beyond the classroom dynamics. And it is it is uh, it is an opportunity to experience mathematics with freedom. So with this understanding, a mathematics creativity test was developed. This test was developed with multiple iterations. It had the test was it went through uh, three rounds of pilot testing. It was administered later. It was administered on more than 590 students. We are trying to develop reliability and validity norms for the test. We are working to develop reliability and validity of the test. So in this session, I'm not talking about how we assess mathematical creativity using the test, but I'm talking about how this test can be used as a pedagogical tool to create democratic learning space in the classroom. So basically, otherwise, this instrument is developed to assess mathematical creativity. It includes both mathematical and non-mathematical, which are generic concept context, and it assesses mathematical creativity of students based on their conceptual understanding of mathematical knowledge and skills acquired up to primary grades. Because this test can be used with different cultures and in different context with different age groups. So we are taking the lowest common denominator, that every student study mathematics at primary till primary grade. So we have taken only those concepts which students across cultures study at the primary level. So it just require the clear conceptual understanding of only those mathematical concepts which are part of the maths curriculum only till primary grades. Okay, uh, so it aims to gauge creative abilities of respondents to use mathematical knowledge in communication, visualization, imagination, creation, and problem solving. So these are some of the variables we are using to assess the creativity. And it can be used as a preferred instrument to judge potentials, mathematical potential of students beyond problem solving. And this instrument can be used by teachers, researchers, gifted educators, and psychologists. Okay, so this is the snapshot of the test. So I'm not talking about how do we use it to assess creativity, but how teachers in general can use this instrument in their classroom as a stimulator to uh, to foster mathematical creativity. So it has two sections. So it has figural section and it has the context based section. There are generic sections and there are mathematical context also. So this is the first. This is up. So I'll take two examples. So the one example on the figural and another example on the context. Okay. So this is, and these context, so these contexts which are written here, activity 1 to activity 7 and activity 1 to activity 8. So these are basically, I'm using them as a stimuli for students a teacher can use in the classroom. So this is a picture and you're expected to describe this picture through a mathematical lens. You can use mathematical concepts, symbols, results, properties, or any other mathematical representation to describe the picture. So these are the instructions given to students. Okay, now I'm taking these two examples, the responses of the students, so there are plenty and plenty of exam responses. So I have just taken some sample responses. So this is a polygon. One of the respondent who's a student in one of the grades. So this is a polygon. It has lot of radius, diameters, all connected at the center point. A figure divided into 24 equal parts. The 12 parts, which is equal to 180, 24 equal to 360. So now if you look at this response, you could see so many mathematical terms have been used. So again, if you go back to the to this image, so you could see the student has used so many mathematical descriptors to describe this picture. So that means you can see the child is talking about polygon, radius, diameters, the parts and equal parts, the counting the parts, the angle measurement, the line segments, the concept of line segment, the concept of circumference. So you could see how many concepts are effectively, interestingly connected to describe the picture. Now here uh, in this it is a much simpler description given by the child. There are 12 total 12 colors. The shape is umbrella. Every color is used twice, so you could see a relation also. The area, the inside area, the inner area, outside area, and the size. So again you could see so many mathematical concepts and the hierarchy of mathematical concepts you could see in the responses. So there are multiple responses, and when we try to categorize these responses, so we were able to we could make more than I think more than 10 categories, and within those categories there were multiple subcategories, because some students viewed this described this image in the form of triangle, somebody in this the polygons. So you could see that it immediately catches the imagination of the child, and it all concepts which are learned through grade 1 to the present grade, child is able to connect all these concepts to describe the picture. Because here there is no burden that it has to be a right answer, it has to be a uniform answer, it has to be a correct answer. Okay. So this is another stimulus which is from section B, which is a context based section. So it says like, I am a clock, I work without rest, moving all day and night. Time keeps changing. So this is basically diary of a clock. So here, if the stimulus says it is the diary of a clock, which is just describing its boredom. So I work without rest, moving all day and night. Time keeps changing, but I continue walking on the same path, round and round and round, all day and night. Nobody thinks about me. I wish I could also move differently with new looks and new rules. So the task for the respondents was, can you make the life of a clock more exciting by designing a new clock with new rules? You can change its outlook, units, or movement. You can add or subtract anything in it. And we also asked, give reason for the changes you would suggest. So I have taken some of the sample responses. So if you look at first sample response, the design has been changed. The clock is the structure of the clock is same. Only the design is same, and the child is saying it should be more. It should be smart enough to tell how much work should we do now, and also indicate us about our pending work. So that means the child is expecting it should be a smart clock. For example, we have smart watches which talks about our heartbeat and the steps we have taken. So again, our next step, a smart clock which talks about our work schedule, which can warn us, which can update us on our work schedule. If you look at this clock, so this is again a 24-hour clock, but here the what the child has done, divided 24 hours into 4 units, and you could see so the 1 unit from 0, which is 24, to 6 and 12. So the 6 hour represents 1 unit here. So okay. So this is interesting. So this is a very simple clock, and it says if the time is 4:30, the clock hand will point towards 30. So here he has written 15, 30 and 45, because here it is 0, which is so only the 3 divisions here, and here you have 1 to 12. So it is, if it is 4:30, so it could be 4:30. If it is 6:15, should be 6:15, but in between there is nothing. Hands will point out according to the time and can move in different directions, okay, instead of round and round. Okay, this is another clock which is talking about nanoseconds, nano units of time. So fine. So then again, the interesting pattern where the clock design is AM, PM, day, night. So if it is 11:30 before lunch, so it is highlighted like this. This is another interesting clock, which there is lot of description, because it is using it is again telling there should be reminders and other things. So rather than the time, there should be instructions on activities. Then okay, so then if you look at this, so in this description, you could see that child has talked about represented used telebars to depict the numbers, and somewhere after the telebars the child is he or she using the Roman numerals. Here if you see, so there is a composite rule of subtraction and addition to describe the time. So this is how you can again move from 1 to 3, so from 12 to 1, and then in reverse order you are moving from here to there. This is again a very interesting, the happy clock, which says this one. This is a design of clock which I personally think looks elegant and homely, with the clock hanging on the tree with birds swings in the flowers. So if all these are with the clock, so she may not feel too bored. If you look at this design, so it goes with the simple line, then double, so and then the triangle. So the line segments are increasing. So 1, 2, 3, 4, 5, 6, and this is how you move on. This is a complex clock with plenty of description. I'm not touching it here. So this is a never-ending, infinite clock where the morning, afternoon, noon, and it continues in a revolving order. And the child is talking something here also where you have two pointers, and so it will indicate the pointers. Uh, this is again a clock with outer circle, inner circle, and it has, if you see the even description 2, 4, 6. So in the unit block is 2 units, and this is how it is moving. And inside it is the unit block, which is in terms of 12, 3. So the unit block of 3. Okay, so this is again an interesting design from Monday to, and then there are 24 divisions in Tuesday, and this is how the clock should move. So it is a weekly clock rather than a day-wise clock. So this is a clock on a linear format. On it is a two-dimensional linear scale. Okay, this is a clock where there is a different representation for hour and the minute phase, and this is how it is. Besides rotating 2 times, clock now will rotate 4 times. This is another description where you have it is in the ball font, and it has 5 units, and you could see very minutely and finely there are 5 divisions with every passing uh, unit of 5. Okay, so these are some of the examples. So there are many such examples, so you could see the imagination, and students had only I think maximum 6 to 9 minutes to draw the clock. Okay, so you could see the imagination. There were examples where some of the students drew a clock in the pendulum form. Some students talked about nano units. So you could see the imagination. Many students talked about smart clock, the value of smart clock, who can update their activities, who can uh, keep account of what they how much they have done and what all is left. So you could see, so all this creativity is encouraged because students, they didn't have any fear that their responses will be judged at right or wrong. We can say that fine, not all models, not all designs could be workable and fit into the criteria of a correct clock which serves the purpose of measuring time. But yes, it does talk about students students understanding of measuring time and the different units of time. It does talk about they are able to relate their understanding on different designs, different units, modular mathematics. Then they talk about you have patterns of twos and fours, and patterns of 5, patterns of 6. So, and the linear scale, two-dimensional scale, how you can convert, you can eliminate minute hand, and you can focus only on the hour hand. So there are the simple designs to to complex designs, there are workable designs to non-workable designs, but definitely students have power to think beyond the structured, uh, depicted structured model of a clock, or you could say the measurement of time. So, so if we talk about, if we use math creativity test as a pedagogical tool, so it allows openness and freedom to think. It gives confidence to think independently, because all students uh, responded independently, so there was no discussion and they thoroughly enjoyed working on these tasks. The only challenge is, because there were around 15 tasks and we gave only 90 minutes, so there were suggestions that yes, there could be more time, or we could make it more shorter. So, but if we are using it as a stimulator in the class, then probably teachers can use one activity per day, one activity once a month. Okay, and then these responses can be discussed, can be shared, can be evaluated, or can be gauged to find out the level of understanding of students. It gives fearless expression, it gives scope and opportunity for fearless expression of their mathematical thinking. There is flexibility and definitely originality, because you could see the so much open, vague, free responses were there. So we can use MCT for the level of conceptual, to gauge their level of conceptual understanding. It can help to diagnose misconceptions, misconcepts among students, because, and it can help to assess their creative potentials. It can help to diagnose the learning problems, learning disabilities, and it can be used as an ability assessment tool also. It can help to transfer, ability to transfer mathematical knowledge outside the mathematical domain. So again, it can help from initial stage of creative potential to higher level of creative thinking. So the first stage, which you could say, where Kaufman talked about the mini C creativity, and here we can reach to we can help students to reach to the more profound level of creative thinking, and where we can talk about outcome oriented creative thinking, where there could be some meaningful outcome which are socially acceptable, mathematically acceptable. So at the beginning stage, at the foundation stage, initial stage, all responses may not be mathematically correct, but it is, so they may not be mathematically perfect, but they are mathematical in nature, because students are trying to use their concepts, their fundamental, their primitive uh, understanding of mathematical concepts into describing these contexts. So based on this, we propose a 5-day teachers training program for teachers to use MCT as a pedagogical tool, and to construct, deconstruct and reconstruct their own understanding on nature of mathematics, because it requires a paradigm shift from mathematics uh, as a mm, as a formal, rigid discipline of concepts, procedures leading to problem solving and mathematical models, to a very open, ever evolving, free spirited subject where their learning can be fun. They too talk about developing a holistic understanding of creativity And within creativity, the domain specific creativity where we talk about mathematical creativity. Day three is focused on MCT as a as a stimulus for promoting creative behavior in classroom. So there is mathematical discussion, mathematical orientation, mathematical game playing. So the sharing, opening up, so there are different strategies, pedagogical strategies using MCT. And day 4 is focused on MCT and learning outcomes of maths curriculum. So if we are using it in the primary grade, so we don't use it, we haven't used it at primary grades, it is from grade 6 onwards, because we still believe that till primary grade students are developing primitive mathematical concepts. So from grade 6 onwards, so you can, how can you map the MCT activities, MCT context with the learning outcomes specified, the targeted learning outcomes specified in the maths curriculum across different cultures. So every state, every education board can map MCT activities with their specified learning outcomes. Day 5 is finally focused on MCT as an assessment tool, where we can use it for ability assessment, ability identification, and diagnostic assessment also. Okay, so and this 5-day teachers training program can help teachers to use maths creativity instrument in their classroom to create to enable every voice to be heard, every voice to be celebrated, without a fear that their answers will be judged right or wrong. So they are no more poorer in mathematics. Everybody can see mathematics from their lens, and everybody can describe and define their mathematical knowledge within the sphere of creativity. So this is with this is the purpose and agenda of the creativity, the math creativity instrument. And if anybody wants to connect with me on this, so this is my email address, so you can connect. So now we are open to your questions and observations.